3.1 Introducing the derivative. This section, we will look at the tangent lines and rates of change, and then the derivative function, and also the derivative notation. For the tangent lines and rates of change, we consider the graph of the s of t, s as the height above the ground, t is the time, two order pairs on the graph. At t equals t0, the order pair is t0, s at t0. At t equals t1, the order pair is t1, s at t1. Draw the line passing these two order pairs. This line is called the secant line. To find the slope of this secant line, follow the formula y2 minus y1 divided by x2 minus x1. And the s at t1 minus s at t0 is called the change in position. t1 minus t0 is called the change in time. Therefore, this slope formula, or the slope of the secant line, is also called the rate of change. If t1 is very close to t0, the second order pair here moves closer and closer and closer to the point t0 as at t0. The secant line will become the tangent line. At the particular point t equals t0. Definition. The average rate of change of the function on the interval ax, which is the first point x1 and the second point x2, is the same as the slope of the secant line. So we use the formula m of secant line as fx minus fa divided by x minus a. Second definition, the instantaneous rate of change at x equals a. This is just one particular point, x equals a. While the average rate of change, we look at the 2 points of time or two separate order pairs. The m of the tangent or the slope of the tangent line is the limit of the slope of the secant line. The equation of the tangent line through the point A, fa, with the slope m tangent or the slope of the tangent line is found by y minus f of a equals m of the tangent line times x minus a, which is from the Poisson form, or y minus y1 equals m times x minus x1. As we know in the order pair a, f of a. Alternative definitions on the interval from a to a plus h. Comparing to the order pair, at the point A and at the point X, where X is A minus A plus H. So from the slope, which is from Fx minus Fa divided by X minus A, replace X with the A plus H, so become F of A plus H minus F of A divided by A plus H minus A. A and A cancel. That gives you the alternative formula as f of a plus h minus f at a divided by h. And again, the slope of the secant line is just the same as the slope formula in general, but slope of the tangent line is the limit of the slope of the secant line. So we call the slope of the secant line as the average rate of change. We call the slope of the tangent line as the instantaneous rate of change. The derivative is another form of the function. So the notation of the derivative of the function f of x, like y equals f of x, we use the dash or the prime to represent the derivative of the function y or the function f as f prime of x, or another notation which is dy by dx. By definition, the derivative or the slope of the tangent line is the limit of the fx plus h minus f of x divided by h. Also, another definition is the limit fx minus f at a divided by x minus a as x approaches a. The derivative notation for the derivative at the point at x equals a, using the f prime at x equals a, or y prime at x equals a, or df dx, put the vertical line on the back and use the lower part or the subscript as x equals a, or dy by dx with the bar, and the lower part on the bottom is x equals a. This representing the derivative of the function at x equals a.